we're going to look at this topic, probability. Now, the word probability, you would have heard it before, and it's used in sentences stating that something has a chance of happening. For example, you might say to your friend, do you think this team is going to make it to the finals? And they might say, probably, right? Probably. It's associated with probability. It means chance, the chance that something can happen. Or they may say, no, probably not. They're not that competent to make it to the finals, all right? Now, probability can be associated with numbers. For example, you might say, oh yes, I am 100% sure that they will make it. Confident, 100%. All right? So, 100% means you are certain. Something is certain to happen. For example, you throw a stone in the air and you say you are 100% sure that it will fall back down. That's certainty. All right? And then that's one extreme. At the other extreme, you have 0%. For example, you're saying that something is impossible. Impossible means cannot happen. And that's 100% or 0% chance of happening. Now, when it comes to using numbers in probability, you have these as the two extremes, from 0 to 100%. But you do have numbers that are between this. For example, 50%. You say 50-50. There's a 50-50 chance of it occurring, which means it's 50% might not, on the other hand, there's a 50% that it might. All right? So you have a range of values from 100% to 0%. Or you may switch it around and say from 0% to 100%. All right? So this is a range of values that probability takes. Now, sometimes you might write probability as numbers. So in terms of percentage, let me use 0% to 100%. These are the values that probability might take. In looking in some books, you might see that it ranges from 0 to 1. 1 represents the 100%. All right? Halfway, you call it 50%, but halfway, between 0 and 1, you call it 0.5. So, this is a range of probability. It cannot be below 0, and it cannot be above 1 or 100%. All right? So, let's look at a few examples when we're talking about probability. Suppose, let's use an example. One popular example would be with these games of chance. You have a certain game of chance, they call it cash pot. And you have 36 numbers available from 1 to 36. These are the numbers that you can play from 1 to 36. Now, if you buy, how much number you buy? All right. You don't buy any ticket. You don't buy any number. Well, they say if you don't have a ticket, you don't have a chance. Your probability, let's use P, of a win is equal to 0%. You have no chance of winning. You don't have a ticket, you don't have a chance. All right? Let's say on the other hand, you buy, suppose you buy all 36 tickets what would happen? Your probability of a win is equal to 100%. You have to win because one of your numbers must play, right? Well, you wouldn't need to feel very good about that. Even though you won, you actually lost money, because guess what? The money that you would get from winning that one ticket would be less than the money you spent to buy all of that ticket, all of those tickets. All right? So you would still lose money, and those who organize the game would benefit. They would be the winners in that case when it comes to making a profit. All right? But you have 0% chance of winning if you don't buy any ticket. You have 100% chance of winning if you do buy all the tickets, all the numbers. Now, notice here that, let me get rid of these up here. Need the space. Notice here that if you consider the probability of winning, the probability that you win is 0. If you don't buy a ticket, what's the probability that you lose? It's 100%. All right? So the total probability is 0 plus 100, which is 100. Now, if you buy all 36 numbers, your probability of a win would be 100%. Therefore, your probability of a loss is going to be, or let me be consistent here, of losing would be 0%. So again, the total probability is 100% plus 0% equal 100%. So if you have two things that can occur, either one or the other, the probability of one plus the probability of the other is always 0%. They always add up to the full probability, right? They always add up. Now, let's look at another situation here with the same game of chance. Let me not erase this part. Same game of chance. Suppose you buy all odd numbers. You buy all odd numbers. So you buy 1, 3, 5, 7, 9, and so on and so forth. Now, half the numbers are even and half are odd. So basically, you end up by 18 numbers. All right, 18 numbers. Now that you buy those 18 numbers, your probability of a win is going to be the 18 numbers that you buy, the probability of them playing, the probability is the 18 numbers that you buy divided by all 36 numbers. 18 divided by 36 is a half, equal 50%. So you can write you can write the probability as a fraction, as a percent, or 0.5 out of 1 as a decimal. So you have those three popular ways of writing down a probability. So basically, you can write it, the number, as a fraction. You can write it as a percentage. And you can also write down the probability in decimal form with your point. So these are the three main ways that you can write down the probability of something occurring fraction, decimal, and percent. So make a note of that. Now, suppose, say, you don't buy 18 numbers. Let us say you choose to buy the numbers 3, 10, and 21. What would be your probability of winning? Your probability of a win would be the 3 numbers that you buy over the total number of numbers that are available. You can divide this down. 3 into 3, 1, 3 into 36. 3, 1, 3, 1/12. So your probability of winning is 1/12. 1 over 12. What's the decimal for that? Let's get our calculator quickly. 1 divided by 12 equals 0.083 or 8.3%. All right. So it is 8.3% or 0.083. You see that? Now, you can come up with a certain definition of probability. Sometimes you might see various definitions of probability being put forward, but basically they cover the same argument. The probability, sometimes PR is used for probability. Let me put it in my words. The number of items that you want or you're looking out for, you're interested in. For example, the number of numbers that you bought divided by total number available. The number of items or events, sometimes they call it the number of favorable outcomes, the number of occurrences that you're interested in, divided by all of them, the total number of occurrences, the total number of events that can happen. All right? In our case, how many numbers you bought divided by the total number of numbers that can play. That is a basic formula for probability. All right? So the number of whatever it is that you want over the total number available. You can fill in the blank of whatever it is. In some websites, some books, they may say number of occurrences or number of events occurring or number of favorable outcomes or whatever it is. All right? So that's basics of probability. You have other examples of probability. In real life, you have, for example, these persons they call actuaries. Actuaries. They studied actuarial science and they're able to come up with some all sort of mathematical formula to predict your chances of meeting in a road accident and therefore recommend how much money the insurance company should take from you in order to make a profit. As a young driver, they charge you more money than an older, more experienced driver. When you go in as a first-time driver, how new your driver's license is as well. If you just recently got your driver's license and you have your car and going in to insure the car, you as a driver, you have what is called a higher premium. All right. Sometimes these modern weather forecasters, they have what they call supercomputer simulation to predict the chance of rain falling or a hurricane coming into your region during the next week or the next month or this hurricane season or whatever it is. They predict, the prediction is really the probability of rain or the probability of a hurricane coming in and blowing you away. So you, in that case, they say you have a more active hurricane season, blowing down trees and blowing roofs of houses, right? Things like that. So those are examples of probability, all right? Wind swooshing and blowing everything away. Sometimes you see, you might notice it already, you see more accidents on the road when the road is wet, because some people believe that they can drive on wet road in the same way that they drive on dry road, all right? And then they happen to pick up a skid and meet in an accident, all right? So you have a higher probability of meeting in an accident, or say there's a higher probability of accidents occurring when the road is wet, because these people pick up a skid and the car runs off the road or crashes into another vehicle or hit a utility pole or a tree or whatever the case may be. So those are examples of probability, right? Now, you have two main types of probability. There is what the one type which you need evidence to back up your claims. You need to have had these things happen before, and then you use past data to predict what might happen. These are called experimental. Let me type it instead of trying to write it. These are called experimental probability. Experimental, experimental, okay, or empirical, I believe that's how it's spelled, empirical probability. Now, in that case, what you are talking about is probability that requires evidence. You ever heard them talking about you need empirical evidence, all right? Empirical evidence you need for something to have happened to support your claim. Experimental probability doesn't necessarily mean that you went into a lab and actually did an experiment, all right? Now, these are probability that requires some data from the past. For example, the weather, predicting the chance of being hit by a hurricane this season or the number of hurricanes that will pass through your region. It could be accidents, right? Motor vehicle accident. There is no set formula that you can sit down and write and say, this is exactly what the probability is for that. You really have to just estimate, even though you can come up with all sorts of formulas to calculate these based on what, well, to estimate really based on what happened in the past, right? These cannot be exactly be predicted by a formula. Now, the other type of probability is what you call classical probability. Classical probability. For example, sometimes you have Person's playing dice. There's a game called Ludi, where they shake the die in the cup and throw it down. You have 6 sides. So classical. The probability of scoring a 3. The probability of scoring a 3 on the throw of a die. Some persons say 1 dice, but what I understand, it's 1 die, more than 1 dice. The probability of scoring a certain number like 3. Alright? So you have really 6 sides. Let me draw my die here. You have that side, then you have that side, and then there are the other 3 sides over there that you can't see. So you have a 3 here. How is it set up? You probably have a 5 here and a 1 here, 4. Then you have a 6 and 1, 2, a 2 at the bottom. But using hidden detail, those who do technical drawing would know what I'm talking about by hidden detail. Alright? So the probability in this case, even before you throw it the first time, you don't have to study it. You don't have to study any pattern from the past. The probability of any score here is 1/6, 1 over 6. That's classical probability. You don't need any evidence from past occurrences. You can calculate the exact probability and say that when the die is thrown, the probability of a 3 showing is going to be 1/6. And then you can throw the die several times, many times. And over time you see that about 1 out of 6 times you have a 3 showing up. Alright? So those are the 2 main types of probability. You have the experimental or empirical probability that requires past data, and you have the classical probability that you can predict even without anything having happened before. Alright? So we'll just end this video for now, but those are some basics of probability. Alright, it's a chance of something happening. You have a range of values from 0% to 100%. 0% mean it's impossible, it can't happen. 100% mean it must happen. Alright? And of course, we look at the fact that various industries use probability in their practice. For example, insurance, and sometimes banks, when you borrow money, depending on your credit score, if you have a poor credit, you borrowed money from before and you didn't pay it back in time, then they charge you a higher interest. So because of a higher probability of you failing to pay back on your loan, they say of you defaulting on your loan, higher probability. Alright? And we look at the fact that you have 2 main types of probability: the empirical probability or experimental probability, and then you have the classical probability. Alright? So what we'll do next time is look at some additional examples when it comes to calculating probability. So I will see you in the next video. So for now, have yourself a nice day.